Okay, let us simplify this algebraic fraction. When you're simplifying a fraction, an algebraic fraction, you want to find a common factor in the numerator that you can cancel in the denominator as well. So in other words, you want to find a common factors between the numerator and the denominator so they can cancel. Now, as you look at these expressions, you're seeing no factors because you're adding and subtracting. And remember, a factor is an item. You're multiplying by another item. So in order to find common factors, we have to factorize both numerator and the denominator. Some persons might be tempted to cancel x squared and x squared. No, that's utterly illegal in this case, right? You have to factorize, and then you can reduce. First of all, let us factorize the numerator. Now, the numerator is a quadratic um, expression, right? And you have techniques that you use to factorize a quadratic expression. In this case, we have x squared minus 3x minus 10. All right. Now a is 1 and c is negative 10. But when a is 1, what you need to do is find two numbers, right? So that when you multiply them, you get this here. You get c because ac is still negative 10. And when you add them, you get negative 3, right? Those two numbers are negative 5 and 2, right? Now since a is 1, since a is 1, right, I don't need to go through the entire process. I found the two numbers to add and get negative 3 that I can also multiply to get negative 10. One of them is negative 5, so I will have x minus 5, that's one factor, and the other number is 2, positive 2, so I will have x plus 2. So that's factorizing the numerator. And now I have to factorize the denominator as well. So I'm going to factorize the denominator here. Now the denominator is the difference of two squares. The denominator is x squared minus 5 squared, right? So you know the formula for this. You use to factorize this. Just use the identity. So we have x minus 5 times x plus 5. Right, that's factorizing the denominator. So let us rewrite this fraction now, write the expressions in factored form. The numerator is x minus 5 times x plus 2, and the denominator is x minus 5 times x plus 5. Alright, so now that we have both numerator and denominator in factored form, now we see a common factor here. In this case, we have x minus 5 as a factor in the numerator and x minus 5 as a factor in the denominator. So these will cancel each other. So your final answer is x plus 2 all over x plus 5. Alright, so just remember, you factorize the numerator and the denominator using techniques that you know, and then if a common factor is revealed, then of course you can cancel that. And in this case, we're left with x plus 2 over x plus 5. Alright, so as you can see, this topic is all about factoring. Once you can factorize, you can handle this topic easily. Let's go to another example. Here's the next one. So we're to reduce this again or simplify it. We don't see any common factors there. We can reduce this, but we can factorize the numerator and we can factor the denominator as well. Let us try to factorize the numerator. The numerator, we have a common factor, x in each term in the numerator, and that's the only one, so we can factor that out of the numerator. So we have x, and x into x squared goes x, right, and x into plus xy goes sy. Alright, that's the numerator. The denominator is the difference of two squares, so we just apply that identity. So we have x minus y times x plus y in the denominator. Now we write a fraction with the expressions factorized. So in the numerator we have x times x plus y, And in the denominator, we have x minus y times x plus y. Okay? Good. So now clearly the common factor is x plus y, and right, so we cancel them. So your final answer should be x over x minus y. So again, it's all about factoring. We want to factor the numerator and the denominator. In these situations, we normally see a common factor revealed, and then we can cancel that. And in this situation, we're left with x over x minus y. Let's try one more. Again, the idea is to factorize both numerator and denominator, then reduce, right? Sometimes, by the way, only the numerator you need to factor, or only the denominator. So let's just see what's going to happen here. With expressions like these, you will need to group and factorize, or what we call using the distributive law twice, okay? So remember all these factor techniques. You have to review that topic to do this well. In the numerator, the first two terms, they have a in common. So you'll have a into x plus y minus the last two terms now. We'll take them to have negative 2 in common, right? So negative 2 into 2x equals x, and negative 2 into minus 2y equals positive y, right? That's it. And then now we realize there is a common factor here now of x plus y. So then we have x plus y into a minus 2, right? That's the numerator factorized. We factorize our denominator. Happens to be the difference of squares again, because it is a squared minus 2 squared, right? So we apply the identity. A minus 2 times a plus 2, right? So then we rewrite now the fraction in factored form, right? So we have x plus y times a minus 2 in the numerator, and in the denominator we have a minus 2 times the other factor, a plus 2. Okay, so clearly a minus 2 will cancel a minus 2, and we are left with x plus y all over a plus 2. Okay, so you can replay the video and go through these examples, and at the same time just recap your notes on factoring, because basically this topic is about factoring, right? You factorize and then to reveal common factors, and then you cancel down the fractions. All right.